All right, for page 2, we're going to have to write the limit statements. I already went through and already wrote the limit as x approaches negative infinity and the limit. So you might want to pause and do all that. I just thought that would make the video quicker because, again, I can't run out of time. So our limit behavior is going to be based on what those horizontal asymptotes are. Let's look at D and E so we can see a graph so we understand why that is. So when we describe the behavior of a function as x gets really, really small, that means we're looking to the left. So we're looking over here at what is happening to the graph. Well, what's happening to the graph is I'm approaching this horizontal asymptote. So that horizontal asymptote is going to be my end behavior. So that horizontal asymptote is 2, so my end behavior to the left is 2. Likewise, if I'm looking for my end behavior as x gets really, really big, here's where x gets really, really big. By the definition of an asymptote, my function has to approach that asymptote, never touch it, never cross it. So it's going to get really, really close to 2. So the limit is going to be 2. The end behavior is that function is approaching 2. So right here, as we look to the left, again, we have a horizontal asymptote. That horizontal asymptote passes through -1 on the y-axis, so my end behavior is a -1. Likewise over here to the right, horizontal asymptote determines the end behavior, -1. The horizontal asymptote determines the end behavior. So up here, when they're asking what the end behavior is, what they're really asking for is, what is the horizontal asymptote? We just figured out how to do the horizontal asymptote. To do the horizontal asymptote from an equation, we compare the degrees. The degrees are the same. So the rule is when the degrees are the same, we take the leading coefficients and reduce it. So our end behavior is 1/3 because that's our horizontal asymptote. Right here, I have the top smaller than the bottom. Whenever the numerator is smaller than the denominator, my horizontal asymptote is 0. So 0 is going to be my end behavior. Because with a rational function, my end behavior is my asymptote. And then finally, for this last one, the top is bigger than the bottom, so there is no horizontal asymptote. However, there is a slant asymptote because these differ by 1. And that slant asymptote is the equation y equals leading coefficient divided by leading coefficient, -3, x to the 4th divided by x to the 3rd, x. So my asymptote is going to be the line y equals -3x. So we're going to have a negative sloped line like this. So when my function goes to the left, as my x values get really, really small, as my function goes to the left, that slant asymptote is going up, my function's going to have to follow that behavior, so it's going up to infinity. As I look to the right, as my x values are getting really, really big, my function is going to follow this slant asymptote. And that slant asymptote is going down to -infinity, so my function is going to follow it down to -infinity. And then finally, it does a little bit more here with slant asymptotes. Again, talks about the degree being exactly 1 different. And you can find that by using this equation, y equals the leading coefficient divided by the leading coefficient. Hey, if your degrees only differ by 1, every time you take this and divide it by this, you're going to end up with x to the 1st. So you're always going to end up with a line. You just want to know, is the line's slope positive or negative? Because that's going to determine your end behavior. So they want to know which one of these has a slant asymptote parallel to the line y equals 1/2. So basically they want to know which one of these has a slant asymptote that has 1/2 as its leading coefficient. So first of all, for slant asymptotes, I'm comparing degrees and I'm looking for a degree of the numerator that's 1 bigger than the degree of the denominator. If it's not 1 bigger, then I don't have a slant asymptote. Here my degrees are the same. Not going to have a slant asymptote. Here my numerator is smaller than my denominator. Not going to have a slant asymptote. Here my numerator is bigger than my denominator by 1. That's important. Then I can take the leading coefficient of the numerator, divide it by the leading coefficient of the denominator, so 1/2. Take x to the second divided by x. X, lo and behold, that one is going to have the same slant asymptote. And then finally, this last one, the leading coefficient of the degree of my numerator is 4, the degree of my denominator is 2. They do not differ by 1, so there is no slant asymptote there. So the only answer here would be C.